And we are live. Hello, HTM community. This is Matt Taylor from NuMIC, and I've also got with me David Ray from Chicago, Fergal from Ireland, Marcus and Scott at the NuMIC offices in Redwood City, and Paul Lamb, who's been a recent addition to our NuPIC community, but he's done a lot of interesting things. So happy to have you here too. I'm going to run over the agenda real quick, which is posted on our forum. The first thing is Chandon hopefully will join a bit later. He's going to talk about the meetup on Monday. So I'm going to push that to the end, give him a chance to join because he's in a meeting. But I do want to discuss something someone brought up, which is what happened to NuPIC 1.0. If you remember, like 2.5 years ago, we had this initiative to get to a 1.0 and what that meant. And the main thing that people wanted to do was to split NuPIC, which was one code base, up into two code bases, one with Python, one with C++. The core C++ having a complete algorithmic set, so it could be running independently from any of the Python stuff. The Python would provide language bindings and also a set of algorithms implemented in Python. But this would allow people to extend the NuPIC core in their own favorite programming language. So they could write a client that binds to the core algorithms that exist in C++ and then create their own set of client tools in whatever language that they want, similar to what we've done at NuMIC in Python. So anybody could do what we've done in Python in any language that they wish. So someone asked, what happened to that idea? Well, we didn't throw it out, but we did have this big plan on how to get that extraction happening. We've done a ton of work, honestly, to make that break occur, and we have got different release processes for NuPIC core versus NuPIC. And at this point, I think it's totally possible for somebody to come in and write language bindings and a client library around NuPIC core, as it is today. But we have not flagged it as 1.0. And in that forum topic, I kind of noted some of the reasons. There's still a few outstanding issues. They're not major. It's things like we don't have enough encoders in C++, so anybody who writes a client would need to write their own encoders. But I think all of the algorithms are there. Temporal memory algorithms there, spatial polar, I think the algorithm set is complete. But would still be work to do, like with anomaly stuff, anomaly likelihood for sure, all that type of client stuff that's currently written in Python and not in C would have to be re-implemented. But the gripe, I think, is what happened to that plan, and why don't we hear about it anymore? And that's a valid gripe because we don't talk about it much because people stop complaining. When we broke up those projects into a C and a Python project, I really didn't hear much at all from anybody about, oh, I want to make my own language binding. How do I do it? No one's asked that. So I kind of figured maybe it wasn't as important as we first thought, as that the community wanted. So if anybody out there is listening wants to write language bindings to our NuPIC core in C++, please speak up on the forums or in the comments or whatever and let us know, because if somebody really wants to do that, I want to enable it. But the only reason I haven't been pushing on this, 1.0 version of NuPIC core is because I haven't felt like there's been much demand over the past year or so. Does anyone want to comment on that before we move on to another topic? Great. All right. Next topic is really quick. If you're watching this and you have problems installing NuPIC, there's a section of our forum called NuPIC. That's the category. That's where to put the installation questions. It's just general discussion about the NuPIC library, which is different from the HTM Java library that David's in charge of. So we have different categories for them because they're different implementations. There's also a NuPIC developers category, which is for contributors to talk about ongoing code development. That's not the place to post installation and build questions, problems about getting it running. So I keep moving those back. So I noticed there's a trend of people posting installation questions in the wrong place. So I just wanted to bring that up. I'm going to keep moving them. And the last topic, aside from the meetup, that I wanted to talk about was this and we had a little mini hangout about this, what, last week, last Monday? We're still trying to get HTM Java running in NAB and producing good scores. We have theoretically it should produce similar benchmark results as NuPIC because they're all the same algorithmically. But we're having some. It's either integration bug or just some type of bug in the anomaly system in HTM Java. I don't think we're quite sure yet still. So I wanted to let David and Fergal have a chance to talk about that. Maybe David, you could explain the current state of what you're doing. I know you've talked about this on the forum. But... Yeah, are you there?
Hi.
Hi.
So my
You don't
approach
have to if
right
you don't
now.
want to, by the way.
No, that's okay. My approach right now is there has been some, I guess, updates to the temporal memory written in Python and in C++ due to Marcus's handiwork with the column segment walk style implementation to try to reduce recursive iterations over the different data sets and make it more efficient. So I was busy trying to debug the NAB and the anomaly system in Java, and the fact that I can't get, due to several different factors, but the fact that I can't get exact same output as the Python just made it a little bit more difficult to just basically debug, so or compare. So my effort right now is I figured out a way to to use a random number generator that produces the same output as, in Python as it does in Java. So I'm busy using that, and I'm updating HTM.java's temporal memory to be in sync with the Python using the column segment walk approach. And I completed that last night. And so I'm going to run the test data. I have a bare bones file which is the same in Python as it is in Java, and it just assembles basically the algorithms together, and you can walk the data through and see the output. So I'm going to use the Python and the Java version side by side, and now that I have an algorithm that produces the exact same output, I can now test and see, where the NAB results are diverging.
So you're in a good place to continue investigating.
Right.
Sounds like. So one suggestion I would say is it's going to be hard to keep up with NuPIC. I think algorithmically, as things are in a bit of flux. As Marcus has come along and made some changes, and I think if you try and freeze your HTM Java version to some SHA, some version of NuPIC, you can focus on the anomaly thing and focus on NAB and not worry about what's going on downstream, because doing them both is going to make both tasks harder.
Yeah, I agree. So I'm not going to update my NuPIC while I'm debugging this, and then following that, I'll update everything. But
okay.
So I've recently found. Sorry. I've recently been in a similar position as you, David, with two different implementations that hit the random number generator in different orders and trying to figure out why they're producing different results. I had this with some of our research stuff with extended temporal memory, and the way I ended up debugging that, because it's hard when the results aren't the same. I had to visualize it. I had to run it and see if similar things are happening, because you expect similar things to happen. Like similar numbers of segments should have grown. Each of those segments should have similar number of synapses. And when I was comparing side by side with that, I would find differences, and that's how I would debug that. I'm not saying you should do that. I think you're on a good path, but I'm just throwing out there that that's another type of debugging I've had to do.
Yeah, that that was the method I've been using for the last year and a half, basically, because as you said, you can't get the same randomly chosen segments and randomly created synapses. So, but the numbers of those should be the same, and the types of outputs should be the same. So the exact numbers should be the same. The numbers should be exactly the same. Whether the actual indexes of the segments and cells and synapses are the same or not. So I agree. I mean, that was the method I was using before, but since I've had my reality tested, my confidence level has decreased a little bit. So I'm looking now for just getting the exact same output.
Sounds good. At least you know what you have there. You know where to start from. Okay. Thanks for your work on that, David. And we'll keep monitoring it. I think when HTM Java is on that leaderboard of NAB, that's a big win, I think, for everybody. So I'm looking forward to that. We're all working towards that. Would be awesome. So the next topic that I have, I think I'm going to share my screen briefly here. So the next topic I have is another forum category called NuPIC apps. Let me steal the screen here. So under NuPIC, again, I mentioned this earlier. There's let me use my whiz-bang feature. Okay. There's developers. This is for us contributors, committers, people who are working on the code base. And then there's NuPIC apps. This is for any questions people have about NuPIC applications that we've been creating and publishing for a while that are all open source. This includes HTM Engine and the code base for Grok for IT analytics, HTM stocks, all that stuff is in here. So if you're trying to get that stuff running, this is the place to ask it, as opposed to somewhere else, maybe HTM Hackers, which is kind of a more general place to just ask about HTM in general, HTM apps in general, building things with HTM, etc. So that is the main thing. Those are the main things I wanted to talk about. Does anyone else want to have the floor for a discussion, bring up a topic while we've got people in the room here that might be able to answer questions?
I just want to know. I just added a method to the universal random generator, random number generator, that returns doubles. So now it could potentially be used inside of this spatial pooler also, and it gets the same output in Java as it does Python. And my method is, just not to have the same precision, to truncate the precision and use the int and truncate the precision and create a double from it. And in that way, you get random doubles and you get the exact same number. You don't get some really weird, trillionth place variation in one language or the other. And I'm able to keep the generated numbers positive too, so I don't get any weirdness there. So it's pretty efficient and it's fast. I mean, because it's an XOR shift, and then so I'm just wondering. I want to ask Scott what his affinity, I'll call it, toward considering that for future use.
Yeah, I'm fine with whatever people think is the right thing to use. I just want to make sure that we go and look through the code and our usage and make sure that's going to handle our use case. Normally when we do a big change like this, we sort of have somebody that can allocate a good amount of time over however long it's going to take to get it done, so that they can sort of initially go through, rather than sort of blindly proposing just based on the algorithm, but actually digging into the code a little bit. And maybe trying it out and seeing what it looks like and whatnot. So that's all I meant, was that I want to make sure we do it right and that we don't have somebody start migrating over and implementing that in code and ends up only halfway done, or it doesn't work out for what we need, and then we're in some bad state.
It's going to be a big change, right? You're going to touch a lot of code replacing this RNG, right?
I don't know. Yeah, potentially. I don't know how big it'll be. I'm not sure how involved that'll be. But David, keep in mind that just changing to that random number generator isn't going to get you exact matches by itself. There's two other things that we have to do. One, we have to make sure that the random number generator is called in the exact same order in the exact same number of times. And the other, which a lot of our code is sort of implemented to match, but I think we would have to start sort of explicitly saying for any function that touches it, in the doc string for it or something, saying this is how many times we call it, and this is the order in which we use it, so that if some other algorithm, does something out of order or whatever, they might have to call the random number generator in one order, but then use them out of order or something to make sure you get the same results. The other thing is, even if we do all of that, we still may not get the same results because we use floating point numbers in a lot of places. There's kind of a separate idea floating around to stop using floating point numbers, but that's an even more involved change, and so just keep that in mind.
Yeah, it's very difficult. I'd be happy. I mean, I want to move as far as we can toward this, but I'd be happy with just having this be officially located inside of the repo, and then for those who want to do language bindings and stuff like that, they can just, throw it in. So just make it possible to use even if it's not officially used all the time. So that I would be happy with, settling on that, because just make it available and let everyone know that, there's a C++, there's a Python, and there's a Java implementation of it, and feel welcome to use it. So if we could make it usable, even if we don't elect to make all the changes necessary to have it be a permanent member, that's fine with me.
This is really tricky because this is not normally part of a software contract.
Right. Well, I mean, we're doing very complex software, and it has very esoteric behavior, and so and it's very difficult for for people. I mean, there's probably 5 people on the planet that can look at the code and actually have some real intuition about how it works. So I mean, what are you supposed to do? And so as the community's affinity toward the code grows, we just need some ways to ease that transition.
So, quick question for Scott about this. Do you think if we're going to do something as drastic as change the RNG for NuPIC, do you think that requires that we have benchmarks before and after, some type of performance comparison, just to make sure we're not screwing anything up?
Yeah, I mean, I think we'd want to run it a few times on some prediction problems in NAB and see what the distribution results look like with different seeds, and then swap it out and make sure it matches.
Okay. So we sort of have an idea of what the scope would be of making a change like that. But I think it sounds like David would be happy if his preferential RNG were made available through the C++ API, so that any other bindings or sort of algorithms that wanted to have parity could use the same?
At least during development.
Okay. Do you think that's an option, Scott? Do you think that's valid?
It's hard to say, I know.
Well, basically keeping more than one RNG, one that's used by NuPIC and one that the NuPIC core makes available for other implementations to choose to use instead.
I don't know. I don't think that makes sense. Right now we have a random number generator implemented in NuPIC core and provided for other people to use. It's implemented in C++. It's not implemented in a bunch of different languages. I don't think it makes sense to add a second one that we're not using. So I mean, we can add that in, but only when we switch over to it.
Okay, so it sounds like the path is replacement, not necessarily having to.
Although I'd also be fine. Well, yeah. I was going to say, if we can agree on random number generator, then at least David can start moving forward in Java, knowing that when we switch over to it in NuPIC, then he'll be in a good spot. But again, I think sometimes once you dig into the code, you find out that there's something you didn't anticipate, and then we may switch to something else. Also, right now, we just have David presenting this particular algorithm. I haven't heard any discussions about the merits of that versus other options. And so, I don't know. I don't think we're quite ready to commit to a specific implementation.
Okay, so let's continue discussion of this where we have been discussing it. In the meantime, David, you're in a place where you can continue working on the bug you're working on, and that's sort of a separate issue.
Right.
So Chandon hasn't joined us yet, so I'm going to talk real quickly about our meetup next week. Let me share my screen again and find it somewhere. Let's just go to the meetup page. So on Monday, this is our, I think, the third Bay Area meetup that we've had. Chandon and Jeff Full are the ones that are hosting this. NuPIC is providing some food and beverages. It's going to be at H2O headquarters. That's in Mountain View. And this has been a lot of fun. And I think we've got more, 60 so far of RSVP. That's more than usual. So we're going to have, show up at 6 if you want to hang out and network and eat pizza or whatever we end up having. Show up at 6. I'll be there. Hopefully we'll have a couple of engineers from the team there. And looks like Marcus is going. So we can hang out, talk about HTM, talk about what you guys are doing. I think H2O, which is our host, and that's actually who Jeff Full works for now. He got a job at HTO. Congrats to him. They're an AI company. They're interested in HTM, so they're hosting our meetup. So they're going to talk quickly about what they do, 10 minutes. I'm going to give a quick recap of what's going on in the open source community, another 10-minute thing. Our director of marketing, Christy Maver, will be there just to give a message from Numenta, sort of just a company update, what's going on there. And then we're also going to have Yue from Numenta's research team coming to give some short thoughts about the current HTM theory, and it really could just turn into a Q&A session. If you have Yue, he knows a lot about the internal research stuff. We can just kind of pick his brain to see what's going on there. And then this whole lightning talks and demos is just kind of loosey-goosey. Some people have signed up to give some talks, and we're going to do it. So Ryan McCall will be there. He's a former intern at Numenta. He's used NuPIC and HTM Engine extensively, so he's been working on HTM Engine to add prediction to it. I think he's going to talk about that, which is cool. I've always wanted that to have prediction. I'm going to run through HTM school visualizations sort of live and explain them and take questions. Not sure how long it's going to take, but yeah, I already talked about Yue. And then Chandon is going to talk about a comparison of popular AI technologies. He's been doing some research in that area. So it should be an eventful meetup, and I'm looking forward to it. Sorry about you guys who are not in the area who won't be able to make it, but I'm going to try and get everything recorded. I don't know how well the quality is going to be. We'll see. But I will have a recording of it online afterwards. And that's all I wanted to talk about today. So if I'm going to give you guys one more chance to speak up about anything. If you want to bring up a topic for discussion, right now.
I have a quick theory question. I don't know. Can you guys hear me?
Yes.
Yeah.
Hello? Okay. Well, hang on. Maybe I'm a little bit crashing this. I'm not really a NuPIC. I'm not really a hacker. I'm more of a user, community person. First of all, big shout out to Matt. Thank you so much. You always answer questions that I have on the forum really thoroughly and completely. So that's awesome. And also your HTM school is just amazing. So, okay, question is, theory-wise, so I'm feeding in just scalar data, and one thing I'm wondering is that what would be lost if, in theory, if we set up the encoder to be sort of the size of, like the encoder, let's say n was 2,048 columns and w was 40. sort of the overall size of the system normally. What would be lost if we fed that encoding right into temporal memory and skipped over spatial pooling in that sense? Because to me, I guess I'm having a hard time understanding why, in the case of just simple floating point values, we actually need spatial pooling if we can create a sparse representation sort of directly from an encoding there. So that's one quick question that I have, because I'm kind of tempted to want to do that, but I feel like I must be maybe missing something there. So more of a theory question, if that's all right.
How about Marcus or Scott? You want to take that?
Sure. I mean, like, it's funny you ask. I've thought the same thing, and I don't disagree. In general, if you're passing one thing into the spatial pooler, like if you're encoding a scalar and then sending that into the spatial pooler, you're right that it's not clear why that's necessary. I think, like, when you need to get a sparse SDR out of just a set of bits, it's useful for that. But I do think you're right that you could make an encoder that just does the whole job. Scott might have a different take on this.
It's just convenience. Even if you have one field, it's easier to pick the parameters that give you a good encoding, and then let the spatial pooler normalize it, the sparsity and everything. But yeah, there's no reason you can't feed it directly. And we've done that in some cases. So when we were doing natural language experiments, we were doing a similar thing where we skip the spatial pooler and feed our representations directly to the temporal memory. That way we could take the predicted cells in the temporal memory and sort of do reconstruction back to the input space. So, yeah.
Yeah, I think the answer is that the spatial pooler is necessary if you need to orthogonalize or decorrelate the bits, the actual choices of bits. So, for example, if you use a serial encoder, the one that slides up and down through the window of the encoder bits, then what you actually want to do is you want to have the individual bits separated. Distributed, basically. So you need to have somewhere where you randomize, or in the case of the cortical I/O encoder, where the position of the bits is actually semantically important. So if that's why you can put the cortical I/O encoder output straight into the TM. Yeah. Whereas if you use the serial scalar encoder, you don't get the same sort of thing, particularly if you use things like local inhibition rather than global inhibition. So at some point in the thing, you need to effectively randomize the spatial positions of the on bits, and the SP does a very good job of that.
And this will make more sense after a couple more episodes of HTM School. The spatial pooler has a lot more options than I showed in the first episode, especially when we talk about local inhibition and topology. That's entirely different subjects. And one other thing, in the real world, it's extremely rare that you're going to have an encoding that has the characteristics that the spatial pooler produces. So most of the time, you're going to have multiple inputs coming in that need to be processed by the spatial pooler for the reasons that Fergal and Scott talked about. The input is not sparse or it's not distributed enough for the HTM system. Can I answer your question?
So one thing I want to mention there is Fergal's right about local inhibition, but we normally don't use local inhibition for typical networks. And if you're just feeding a single scalar value in, you wouldn't probably use local inhibition. And so I don't want people to get confused and think that there is a relationship between bits that are close together. As far as when you're using local inhibition, as far as the temporal memory and everything's concerned, the bits next to each other are no more similar or dissimilar. The bits very far apart. And that's not, when we say distributed, we don't mean that the ones are sort of randomly scattered around the input space. Distributed has a very different meaning there. So just want to make sure we're not confusing those two things.
So what does distributed mean there?
It means that the semantics of the data that you're encoding is distributed amongst the bits that are active. So
it doesn't matter if they're close or not.
Right. And overall meaning is made up of the combination of the.
Okay, so that would mean then that all of the semantic possibilities have equal representation somewhere in the bits.
I don't quite follow that.
So if I have 5 semantic meanings that I'm encoding, or semantic variations, then all 5 will have a bit or more than one bit that is responsible for representing that semantic meaning.
Well, I don't think that's guaranteed. When you
Okay.
construct encoding or whatever, it could be that some semantics just simply aren't captured by your encoding scheme. There are no bits that represent that semantic, and it gets lost in your encoding.
Right, but just assuming that the encoder encodes that, then eventually the spatial pooler will represent the entire set of possibilities, right? I mean, as it goes on, inhibition will sort of have each bit compete for the possible meanings, and as time goes on, it will settle so that all of the meanings have some representation.
Yeah, that's correct. But the particular thing that I think Scott is talking about is the fact that what you don't want is that you don't want the semantics to be dependent on a very small number of individual bits. And
Right.
what you really want is that.
Oh, okay.
Yeah, so the idea is that, for example, if you have a serial encoding, like the serial scalar encoder, if you just look at that, then from a certain point of view, many of the bits are effectively on-off bits, right? So you need to have these particular bits mean a 5, and
Right.
plus or minus a little bit of uncertainty, right? So a lot of them will stay on. Now, that's what you want, but you don't want that there's some direct, like, topological connection between those particular bits and the eventual output of the system. Because what happens then is that if there's some failure in the thing where it's not looking at a sufficient number of bits, what you want to do is share the semantics out as many bits as possible,
Right.
so that any particular
subsampling,
any particular subsampling of those bits is just as good as any other. Yeah.
Right, and it's noise tolerant as well because of that.
It's noise. It's everything tolerant, and and there's a reason why it's called over completeness in the mathematics, basically. But the way that it's ensured in the standard way that NuPIC is used is that you put in a layer that basically randomizes the connections, so that even if the thing is very correlated on the input or the encoder side, that by the time it gets to the TM, which is the important part, then the individual bit position is not as important as it would be at the encoder stage.
And you can see that really clearly at the end of the last spatial pooler HTM school, looking at the active bits, active columns coming out of the spatial pooler and the encoding. You can look at the encoding and tell what the data looks like. You can't look at the active columns and tell what it represents at all. But it does represent the same, pretty close to the same thing.
Yeah, and this is particularly important. I mean, this is the work that we're doing because we're doing stuff in GPUs. And this is a big problem because you have to basically spread out where the information is coming from when you're using local inhibition. And at large scale, when you have a lot of units, you need local inhibition. So and you need to also have the choice. So if you're doing things like vision or auditory or anything like that, where you have very high dimensional inputs, and I think the same is also going to be true of the cortical I/O, where you have 16K binary inputs, then you're going to be using local inhibition at some point, and at that stage you need to make sure that your representation is distributed in a spatial sense as well as in a kind of a abstract mathematical sense.
So we're running a little long. I want to give a chance to anybody else who wanted to ask a question before we close. Thanks, Sam. I hope that helped you out.
Oh yeah, thank you guys. That's great. That's great.
All right. So anyone else want to chime in?
One more quick question, if nobody else has one, and we can cut it short. Very quick. Okay, so I just want to make sure I understand this right. So right now I'm feeding in one value, but I want to eventually feed in 4 values because it's a one-dimensional thing, but it's going to be a 4-dimensional thing. If I have it right, then what would happen in the current NuPIC system is that it would scale to 4, but not really more than 5, right? Because then it starts to kind of get overcrowded in terms of number of streams to be fed in. Because if I have it right, that you would take each value and sort of the encoding of each of the 4 values and concatenate them and then feed that all into the spatial pooler. But then if the number of values gets too high, then is it that it would just become very slow, or that the space would become sort of too saturated with on bits? Or no, the spatial pooler would only activate 2% of bits regardless. I guess, well, I'm interested in the idea of scaling out potentially a high number of variables. If you had many variables, let's say you had like 100 variables, but only like a few of them actually turned out to matter, like 6 of them turned out to matter. So where you could feed in all of those streams, and then it would eventually sort of discern that, you know, it turns out that 90 of them actually don't really matter, or they seem to show no real pattern, whereas the real pattern is coming in just a few of them. I don't know if that's a coherent question, but I don't know. Any thoughts there? Or we can skip it.
At least on, so the last thing you were talking about is something that swarming helps with. If you have a lot of different inputs and you don't know which ones contribute to the prediction of the thing that you want to predict, you'll run a swarm on it. And the more inputs that you have, the longer the swarm's going to take, because it's going to try different iterations of, or different permutations of encoder parameters for each of those inputs and try and find which ones contribute to the prediction the most. So that's one way, I think, to identify what fields in multiple input scenarios contribute to the prediction. But it takes a long time, especially if you have hundreds of inputs. I'm not even sure if it'll work well. And the other question, maybe you guys in the office can take. I don't know.
I don't have anything super insightful to say here. Like, there are a couple different kinds of performance. I don't think we're talking about the speed of the code here. I think we're talking about how well it, like, what the results are. And I mean, if you're doing, are you focused on anomaly detection or on prediction right now?
Right, it's on. Well, okay, essentially anomaly detection. Well, it's sort of both, because we're trying to basically look at these streams that come in, and it represents a certain person's control behaviors. Like they're landing a plane, let's say, they would have 4 different controls they would use to land the plane. So we want to see a plane landing and not know who it was, but then try to determine which model best explains that behavior. So we say, oh, that must be Scott who's landing the plane, or that must be Matt, or that must be somebody else. So we're trying to basically match a output with a model that we've learned, having learned multiple models. Does that make any sense?
Yeah, but so
are you gonna say that?
I don't know. So there's a hacky way to go about this, because you basically you're trying to classify behavior through a stream of events, essentially. Mm-hmm. So the way I've tried to do this before, and your mileage may vary because I'm not sure how well this works on different data, but if you can train one individual model for each of the classifications and feed in just that data to each one, so you've got one for Matt, one for Scott, one for Marcus, whatever, and have each model learn the typical event stream over time for each person, mm-hmm. and then send a live stream of data that you don't know who is operating the plane or whatever to all those models at once, and then sort them by anomaly likelihood or anomaly score.
That's it, yeah, the anomaly likelihood, which you recommended on the forum, yeah.
Yeah, so if you sort them by anomaly likelihood and take the lowest anomaly likelihood, that would be your winner. That's currently who it thinks is at least most similar, and the stream is most similar to what it's seen in the past. And this, like I said, it's sort of a hacky way to do it. It's not biologically plausible. That's not how your brain is doing classification, but it's a way to do it with HTM.
Wow, does that work? That sounds cool.
I don't know. Theoretically.
You could also, I mean, another way you could do this with one model, and I don't know how well this would work, but a pretty straightforward way to do this would be to whenever you're starting a new person flying, you do a quick reset, like you reset the HTM, which doesn't change it, just makes sure it knows that you're starting a new sequence. Then you just go and you let that person fly, and your classifier, like you'll have a classifier that's like learning all of these. The classifier looks at the state of the temporal memory, and you label it as like this is Scott flying. This is Scott flying. Just every part of the sequence. And then like what you're going to get is a classifier that can look at the model at any time and tell you whether it's Scott flying or Matt flying or whatever. So you could do this with one model on the classifier.
So then you would have one model where you show it the first person flying, and then reset and show it a second person flying, reset, show it a third person flying, and then you've got this model that is so everybody's sort of compacted into one, and then show it a stream, and then we could say, oh, that's probably Scott, or that's probably Marcus, or whoever, or nobody.
Have mappings from tons of cell SDRs basically to names. So it'll in general be able to look at different. Yeah, that would, you know, I can see both of these working. The anomaly detection one might actually be better now that I'm thinking about it a little more. But there are different ways to do this. Your original question was about like number of fields for this. That's a complicated question. Because one thing about passing in a lot of fields is that the anomaly score is now being determined by a lot of, it's kind of spread around, like your different columns that are being spatial pooled over are their meaning is going to be like, there might be like the fraction of the meaning that is given to, I don't know, the velocity is going to get smaller and smaller as you add more fields, so that suddenly like a huge anomaly in velocity will cause a minor anomaly in score, if that makes sense.
Right, because they're controlling different things, so if they do something anomalous in one of the controls, then that might get sort of lost within the...
Yeah, you can control that. You can control how heavily the different values are weighted using encoder parameters. Like you could use a larger space to encode something with more on bits if you think it's more important, right?
Right, like that weighing problem. You talk about that in one of the videos where you have to have, you're gonna weigh things more than others. If you sort of dedicate only 2 bits to whether it's weekend or weekday, then that's not going to get weighed very much. So you could control it through weighting. Is that what you're saying? Yeah.
You could, and I mean this is where the tuning of HTM becomes important, because you can't just swarm on something and just take the model parameters that you're given and expect it just to do really well. Like at this point in the evolution of HTM and HTM systems, you sort of have to understand it well enough to do this type of tuning if you're trying to apply it to a particular problem like you're doing. And knowing that velocity changes are much more important than altitude changes or attitude changes is important, right? You, the subject matter expert, know that. The system's not going to know that unless you encode it to know that.
So that'd be sort of a pre-processing step, where you could say, maybe this certain control distinguishes pilots more so than another one. We could weigh that more so in the encoder and sort of dedicate more bits to that variable if we know that it's more distinguishing.
It could just be a research step on your part, just to set up the system to know to weight certain values more heavily than others. You may not have to pre-process it if it applies globally to the data set.
Yeah, so that's essentially what swarming is designed to do. And what it basically does is that it runs a simulation of your task for a certain amount of time, and it measures how well the prediction works based on how it encodes the information, how it combines different fields, and so on. One possible thing that you might consider is to talk to Francisco, because one of the things that he's doing apart from the language stuff is the abstract semantic folding, and he's been dealing with very high dimensional data, for example, from NASA stuff, and basically his system effectively performs that pre-processing step. So it looks at a large amount of data and then it figures out how to map that into a consistent encoding, and does all that pre-weighing and combines. I think he was telling me even a year and a half ago that on some of the aircraft that they were measuring, that they were getting 186 different scalar inputs, and that his system was, what NASA were talking to him about, was basically turning that into something that was an SDR representation that would be directly fed into something like HTM.
Yeah, it's a hard problem, and swarming isn't a complete solution. Swarming points you in the right direction generally, but then manual tuning is usually necessary for a certain problem space.
Yeah, when you get into something like when you have, like, I'd say 3 or 4 dimensions is no problem. Even double that becomes a big problem.
Yeah.
If you just feed in unfiltered, unweighted data that has no domain expertise feeding into it, because what you're doing is most likely that 2 or 3 of those variables are going to explain 90% of the variance. And
that's a good
what you're
point.
doing is you're killing those variables if you just give equal weight to what's effectively like tuning into a random radio station and just feeding in that value. And that's literally what it is, because a lot of these things are just not important.
Yeah,
when you get into beyond that, then you're in trouble.
Several times I've been shocked running swarms and finding that there was no correlation between input fields that I suspected had a direct correlation to the predicted field. And generally, the reason is because the predicted field has all of the information the system needs to make the prediction. Like for example, rainfall and water levels or something like that, or flood or something. It makes sense in your brain that rain causes floods, so I should be able to tell that when rainfall goes up, flooding goes up. But basically, the system can predict without the rainfall that the flooding or the water level is going up, just because that's the seasonal pattern of the data. It doesn't need the rainfall. The rainfall is the cause, but it doesn't necessarily need to know the cause to predict the effect, because it sees the effect over time, right?
Yeah, and Subotai said this.
Yeah,
Subotai said this, that in a talk, I think about 3 or 4 months ago, that if you give too much information to the system, it actually makes worse predictions.
Yeah.
Yeah.
That was when he was talking about the CLA classifier.
That's right, yeah. So I'd go over that talk as well, because that's important. So sometimes the fewer variables you put in, it kind of doesn't matter with 4, because 4 variables is effectively, it's order 1. But once you get towards order 10, you're very likely to start polluting your encoding.
Yeah, start small. Try and identify what you think is the most important handful of fields, and start there, I would suggest.
Yeah, I don't even, because I'm interested in streaming analytics like you guys do. I don't even know if, in many practical purposes, you would really need to be taking in so many more streams. Like, it could probably boil down to a small handful in many cases, but I know you guys would probably know more about it since you've been dealing with companies and things like that. So if you're finding that, then that's good with me. I just am really interested in the idea of being able to scale it, potentially being able to scale it, and thoughts on that board. And thank you guys so much for spending so much time on my questions. I totally just crashed this party. I don't contribute to the code base or do anything. I just try to get it installed, which is already enough of a challenge. Yeah, so thank you very much. I'll let you guys get back to what your important stuff you're talking about.
Well, I think we're pretty much done.
Oh,
this is generally a 30-minute meeting, and we've gone over, which is great. So I'm happy to have you here. Curious, Sam, what's your HTM forum username, so I can recognize
it's
you?
I think it's just sheiser1. SHEISER1. I asked about handling multiple fields with hierarchy some time ago, and also basically the same question I asked today about, and you recommended using the anomaly likelihood, and you said, can I see a little of your data? And I know you deal with a lot of questions, so it's probably not coming right to mind, but yeah, I'm a graduate student working in this stuff, and I just think it's totally the most interesting, oh, sorry, that's my dad, the most interesting stuff that I've come across, so yeah,
Awesome.
I'm so glad that you guys are so open, and I'll be asking more dumb questions up there if you have time to deal with that.
Yeah, just who's the naked dude in the background?
Yeah, sorry, that was my dad. I didn't think about the angle there.
It just adds some flavor. It's fine.
Yeah, I'm on family vacation, so.
Okay, here's an homage to UA to end everything with.
Inside joke. So yeah, so UA is going to be at our meetup on Monday, and we kind of make fun of him a little bit because he uses this 007 picture of him. It looks like he's 007. He's like got a little tuxedo on, and he's it's just fun. Anyway, we love UA.
And do record that stuff if you can. I mean, obviously, I would certainly watch it. Hopefully, others would too. But
I will.
It'll look really interesting, and I'm all the way in New York, so can't really.
Thanks for joining, everybody. I will record the meetup. It might take me a few days to get it online. It might take me a week to get it online because I have to put out an HTM school next week. I have no idea how I'm going to get this done, but we'll work on it. So we should probably wrap it up. We're running late. Big thanks to everybody who joined. It's a whole lot better than last month. Appreciate it. Goodbye, everybody.
Cheers, man.
Thanks so much, everybody. Appreciate it a lot.
Bye.
Take care.
Bye.